Hello students, in this topic dynamics or laws of motion, the next problem 96th ones. In this water jet is falling on the block. Generally if a gap is there, water will take the parabolic path due to the gravity and falls on the ground. And even it just before touching the ground, if it's striking the wall also, same problem we need to take. It may take the parabolic path and strike this block. Block is on the smooth surface, no friction is there. Then what is the question is, what is the instantaneous acceleration? The instant only, because if the distance increases means afterwards the force acting on this block will change, because the distance is more means impact will be less. When it is close to this, we are taking the small gap, imagination, water striking almost straight, we have to take area of cross section is A, but if area is given, use the different formula, area not given means different formula. In this you are given the rate at which the water is striking is given as 1 kg per second, that means mass by time, careful with the formula, and the velocity of this water jet is 5 meter per second speed, and block mass is given as 2 kg initially at rest, and they are asked to find out the acceleration. Sometimes they will even ask the final velocity also. If you know the acceleration means you can find out the final velocity from v equal to u plus at or v square equal to u square plus 2s. They may ask even how much distance travelled also, or work done equal to change in kinetic energy formula also we can use that to find out in the velocities. Here mass of the block is 2 kg initially at rest, and find out its acceleration. Force acting on the block by the fluid, we have the two formulas for the block. F is equals to ma, this action, and what is the force exerted by this water in terms of the rate of change of the mass they gave you is a dm by dt, this amount of the water flowing out with the speed constant given for the small distance v into dm by dt. You are asked to find out this acceleration. So F equal to ma for the block is also equal to for the liquid v equal to dm by dt. We have the formula, another formula, F is equals to rho a into v square, we discussed in the previous class, previous problems working. Here v square, rho a v square, a is area of cross section if they given, use this relation. Density of the water, if it is density of the water 10 to the power of 3 kg per cubic meter you have to take. They don't give the density of the water 10 to the power of 3 kg per cubic meter, but you are not given the area of cross section of this fluid, so don't use this relationship. In this case we have to use this F equal to ma equal to v into dm by dt, a equal to v by m into dm by dt. V is 5, mass of the block is 2 kg, all SI units you are taking, dm by dt is 1 kg per second, the result is 2.5 meter per second square is the acceleration. If you are asked to find out what is the distance travelled and etc., we can take a v square, v equal to u plus at, after what time it comes to, friction is not there, means it has to continuously move with the same velocity, but initial acceleration is a, whatever the velocity comes at that instant has to proceed with this straight line directions. Okay, next 103. Okay, one more thing is, if the friction is given, mostly they don't give, the friction is given, then forward force minus frictional force is nothing but equal to m into a, resultant force you take it up. Forward force is this value v into dm by dt, forward force, minus fs, f minus fs equal to resultant force equal to m into a, we have to take fs is the friction, or fk will be taken dynamic friction, static friction. Friction is always equal to coefficient of friction mu into m into g, capital M into g. This is a weight for the normal reaction will be acting upward directions. Normal reaction is nothing but equal to mu into weight mu mg, n equal to mg, upward force equal to downward force, n equal to mg, and friction force is mu mg, mu into normal reaction is the friction force. Okay, but in case if the friction is asked only, at the resultant force equal to ma, otherwise not required. In this problem it is not there, just leave it. Smooth surface means no friction. Smooth surface or frictionless surface, meaning is same. Next is question number 103. Object of mass 2 kg, u equal to 4 meter per, has the initial velocity 4 meter per second, is already in motion with velocity u, and it's coming to rest after time t 2 seconds. Final velocity v equal to 0. Initial velocity is 4 meter per second, final velocity is 2 meter per second, is coming to rest in the time of 2 seconds. Coming to rest means v is 0. You are asked to find out what is the force required to keep the same object with the same velocity, to keep constant velocity. equal to constant. That means object has to move with the same constant of speed of 4 meter per second in the same straight line direction. What is the external force required? Here it is coming to rest means frictional force is there. Frictional force is opposing the external force you are applying. If you don't apply continuous external force, just push and leave it, it travels some distance and come to rest. Then if you want to continue to move, then whatever the frictional force is there, equal amount of force you have to apply opposite to the frictional force, then net force is 0. It is possible to maintain the velocity constant, and net acceleration is also 0. So in this case, first calculate what is the retardation producing. Retardation is negative acceleration. So you will get this retardation is F equal to ma. Retarding force it is. Retarding force is F equal to ma. A is retardation. Ma equal to V minus U by T, but come interest V is 0. You will get the substitution of this U is 4 meter per second by time is 2 seconds, 4 by 2 into mass is 2. 2 into 4 by 2, 2 to cancel, so you will get is minus 4 is A. Sorry. F retarding force is nothing but equal to minus 4 Newton. Minus means opposite direction. Acceleration is negative retardation, we can say. So what is external force? Then external force is opposed to the retardation, means external force is minus of retardation. So minus of minus becomes equal to plus. External force required equal to 4 newtons. So this side is 4 newtons. Frictional force is also 4 newtons. Net force is 0. This mu n is not required because the data is not given to that. Whatever the data given with this, that only you have to take. Just a friction opposing force we can just take. Next, triple one question number. One hammer is hitting, this multiple times asked, very important ones. Hammer is hitting the nail and nail is penetrating into the block. This problem will be mostly asked for the NEET and JEE cases. KCET rarely asked, but NEET, JEE important. Olden days they used to ask even KCET also. But block of this hammer of mass capital M hits the nail of small m and it is drawn into and pushed into the wooden block of mass not required because the mass of the nail only required for us. Block mass is not required, it is not in motion. So nail is penetrated into the distance equal to x. Just before hitting the nail, the mass of the block is m, its velocity is u, so momentum becomes equal to mu. After hitting both are in contact and move with the common speed initially is equals to m plus m into v1 will be the momentum. Common speed is v1 for both. But after penetrating into the enough distance that block provides the retardation, upward directions, retardation, negative acceleration, and due to that reason it comes to rest. And the force acting on this block is pushing it downwards, retardation is upwards, the depth to which it is drawn inside is given in the textbook in your problems as symbol with A. It was previously asked multiplies with the symbol A to confuse with the retardation symbol A. So in such cases what you do is, one you take A, another one you take as A prime also, that is left to your choice. So don't take this as acceleration, this is a depth A given, I am taking it as X. This is a retardation upward direction, this is X. Next, just before hitting the nail, momentum is conserved here because there is no external force. Combinedly two systems are taken as one system means, two objects are taken as one system means the forces will become equal to internal forces. Mass into velocity of the hammer is supposed to be equal to final after hitting, like a collisions. After hitting, that both are combinedly moving together by touching, the total mass into common velocity. Common velocity is nothing but equal to v1, m plus m into v1. Momentum before equal to momentum after. From this you have to get the expression for v1. v1 is nothing but equal to m into u by m plus m. We need that thing later. Next, what is work done? Work done in this case is nothing but equal to force into displacement. Work done is also equal to change in kinetic energy of the nail plus hammer. Both are coming to rest. After hitting, it goes and stops. Then F into X is nothing but equal to change in kinetic energy is half final kinetic energy minus initial kinetic energy. Final kinetic energy is V is equal to 0 we are taking here. V equal to 0 and just before hitting, the velocity is V1 we have taken. So here, final velocity V equal to 0. Half m plus m into initial velocity square only, final minus initial negative comes, but take it as a magnitude only we have to take for the kinetic energy. Because the acceleration is retardation we are getting anyway, that is a negative. Force we want to find out, F is equals to 1 by 2x into 1 by 2x into m plus m into v1 square. v1 you are taking from here, m square u square by m plus m whole square. This m plus m cancels, the result is F is equals to 1 by 2x m square u square by m plus m. They don't give with the values, they will give only with the symbols. Next, 117 problem number. Find the acceleration of the wedge. Wedge means a triangular surface, cross section. Wedge, acceleration of the wedge A we have to find out, so that the block on it, falls freely. There is a block on this wedge or a triangular surface and the inclined surface. The inclination is theta angle, and what is the acceleration A, so that this will not slide. Instead of sliding, it just falls straight downwards. So it should fall straight. As it's going upwards, forward direction, right hand direction, this should fall like this instead of sliding like this. That in that case, what you have to take is in the vertical directions, these forces you have to resolve into components. Whenever the normal reaction is present, whenever the block is pushing to the surface, that weight is mg's action. Reaction is acting perpendicular to surface, we call it as a normal reaction. Action is equals to normal reactions. So in case if this is not exerting force on the base, then normal reaction is 0. We say the object is experiencing the weightlessness. Inside the orbiting satellite, normal reaction is 0. If any object is falling one block over the other block, you keep it. And a person with two blocks and with a block on his head jumping from some height, both are freely falling cases. Acceleration to gravity is g. Before touching the ground, he is carrying no weight. Why no weight? Because both are falling with the same acceleration, and the weight is not exerting on him because the acceleration is same. So normal reaction n equal to 0. Whenever any object falling freely, if you are taking means you have to take its normal reaction equal to 0. The normal reaction is also called as the apparent weight. That weight that appears is 0. On the inclined surface, if you are taking this normal reaction, it becomes equal to mg cos theta. Mg is the weight acting vertically downwards. Normal reaction is pushing onto the inclined surface. The normal reaction in this direction, and mg is resolved into component. This is theta, this is also theta. This becomes equal to mg cos theta. Normal reaction equal to mg cos theta on the inclined surface. On the horizontal surface, n is equals to mg, balanced. On the inclined surface, n equal to mg cos theta. You have to remember this relation. For the inclined surface, resolution of the force is important here. If it is not touching the surface, then it is supposed to fall freely only, not vertically downwards. So here in this case, there is this block is pushed right hand direction, then the small block, the wedge is pushed right hand direction, then small block experiences a pseudo force in the opposite directions. If the bus is moving suddenly forward, you feel force acting backward direction, that is a pseudo force. If the suddenly brakes are applied for the vehicle, you are inside the vehicle and you will fall forward, that is a pseudo force. That is due to inertia of rest, inertia of motion reasons. So in this case, the pseudo force is resolved into components. The inclined surface along this, the weight of this block is mg sin theta component. This is mg cos theta. This side is mg sin theta. So, but however, it is not required for us just to take the analysis. Mg resolved into components, mg sin theta, mg cos theta. This is theta. This is also theta. And force F is acting opposite to the motion of this wedge. So this pseudo force F is nothing but equal to ma. This is pseudo force. F is nothing but equal to ma resolved into components. Two perpendicular components you take. One is in this direction, another one is perpendicular to this in this direction. This force is nothing but F cos theta known angle side. Other direction is nothing but equal to F sin theta. So this force F n plus F sin theta, n plus F sin theta is supposed to be equal to mg cos theta. When in that case this is a balanced force. This is unbalanced force trying to pull it downwards. This is a balanced force equal to n plus F sin theta equal to mg cos theta. But free fall condition, normal reaction is 0. It is not pushing the surface anymore. Then that case F sin theta becomes equal to mg cos theta. But F is nothing but equal to pseudo force is small mass of the block into its acceleration. Whatever acceleration you are taking to the right side, connected bodies all should have the same acceleration. Here backward direction you have to take for the pseudo force. So this becomes equal to F equal to ma, substitute here ma into sin theta, because n is 0, ma into sin theta equal to mg cos theta, cancels. So a equal to cos theta by sin theta is cot theta. There are two cases in this block on the wedge. You can take right side or left side motion may be given, and this is one case. Another problem is also important. This is also important. Don't work out second time, please. There are only two types of the cases. One is falling freely. Second one is even it is pushed this side, it should not slide up or downwards. It should be stationary. Two cases are there. Here moving it away so that it falls straight freely. This is one case. Another case is pushing left side so that block is at a rest. That problems after this we will discuss. Next, question number 115. Here two blocks MA and NB are connected with a spring. MB right head, you may be given M1, M2 or AB, this may be A, this may be B, symbols can be changed. This block, first block B is pulled with a force F. They mentioned it as not with the diagram, may be mentioned, they told that MB is pushed with the force F. So you not applied force here, you are applying the force here, it means pulled this told. And pulled with the force F, applied with the force F, so that its acceleration is AB. But spring opposes this because of the other block. Due to that reason, the tension is created in the spring, the tension is nothing but equal to T. The tension in the spring is equals to F equal to minus Kx. According to Hooke's law for the springs, the force in the spring is nothing but equal to minus Kx. Minus, if you are taking, means that is supposed to be restoring force inside the spring. If you are taking the external force, you take it as a plus only. Internal force minus, you have to take it up. Force is proportional to extension of the spring x. X is the extension of the spring, or it may be taken as T is the tension. This Ex is the elongation or extension or compression. It can be taken as a compression for the same formula. Same formula applicable for expansion as well as compressions. So T equal to Kx. Same tension T is pulling the second block in this direction. Instead of spring, if you pick a rod or inextensible rope, both will have the massless rope. Both will have the same acceleration. Connected body should have the same acceleration. If in between connected material is non-extensible, but spring is there, means it has to expand first. Due to that reason, some energy for some forces can decrease here, and other block does not move the same acceleration the first block, and second block is pulled with the tension T. Next, the spring, for the spring tension is nothing but equal to Kx. Tension is the force inside the materials. T is the tension and X is the elongation. In this case, elongation, expanding it. Tension T is providing the acceleration for this, that is as a force F. T equal to m mass into acceleration of A, block A. That is also equal to Kx. Next, acceleration of the block becomes equal to Kx by Ma, and in the question it is given that Ma equal to Mb. Here given as Ma equal to Mb equal to M. Identical blocks, same masses. Next, block B, if you take a F minus T, tension is opposing this, net force you have to calculate is F minus T equal to M into A. That is for the block B. F minus T equal to Mb into AB, or F minus T substitute from the previous relationship, Kx substitute here. Kx equal to M into A of the block B. Then acceleration of the block B becomes equal to F minus Kx by Mb. Here also we take it as equals to Mb equal to M only. But they asked not acceleration, they asked is relative acceleration. Sometimes they ask only the acceleration also, second block, but here relative acceleration they asked. Relative acceleration is nothing but equal to same direction of motion. Difference of the two acceleration is the relative acceleration. First block has the most acceleration, therefore AB minus AA is equals to F minus Kx by M, minus Kx by M. So denominator mm same, so minus Kx becomes equal to minus 2Kx by M. Next, 121, and this topic problems are very important. Don't work out a maximum, more than one question comes from this topic, so you have to work out every problem from the material. 121 problem number, bullets each of mass 0.03 kg, bullet mass. We take the small m symbol, hit plate, one plate is there, and hitting the plate at the rate of 200 bullets per second, and with the speed of 30 meters per second. Find the force acting on the plates. You have to imagine, if they are not mentioned, final velocity is 0 after hitting the plate. The bullet is coming and hitting this plate. Is a plate of mass capital M, the bullet is hitting and coming to rest, means final velocity is 0. Sometimes they will give you the final velocity is coming back down with the same speed, the formula will be different. So if you are hitting and then final velocity becoming equal to 0, then the momentum is, change in momentum is nothing but equal to mu, initial velocity is u, mu, and final momentum is mv, v is 0 here. So initial momentum only we need to consider here. Force is nothing but equal to rate of change of momentum. Each bullet momentum is mu, and rate of change of momentum is mu by t, means dt or t I am taking here. That mu by t is nothing but equal to momentum by time is supposed to be force, external force. So, but you are n bullets are striking one after the other very fast, then the number of bullets you have to multiply with n into mu, momentum of the bullet by t. Here change in momentum, it is actually change in momentum means mv minus mu. Mv minus mu is mu only. Negative sign don't take here, negative sign negates related to the action reaction forces. So we are taking only the magnitude of the force. Mu by t. Substitute the values here, number of bullets per second, n by t it is 200 by 1, mass of the bullet is 0.03, u is 30. The result is 180 newtons. In the same question sometimes they will ask in the other different ways. 1. is what is the weight of the plate, they may ask you. What is the mass of the plate, they may ask you. If it is at rest by striking this bullet, what are the force applied by the bullets is supposed to be balancing the plate, continuously striking the plate with the bullets one after the other. The plate trying to fall downwards, but because of this hitting on the bullets is not falling down, it's stationary there. And after hitting, the bullets coming to rest, falling free and falling out, falling becoming with velocity 0 and falling to the gravity g. Don't consider that part. When after hitting, the velocity become equal to 0, so falls freely due to the gravity effect, that don't consider it. So in these cases, final velocity of the bullet 0 means whatever the force exerted here is supposed to be getting this much is supposed to equal to weight. Upward force is balancing the weight of the blade, so equal to mg. G is 10 means m you can calculate mass of the plate. This F by G is nothing but equal to m. And other case is that they may say that final velocity of the bullet is same after hitting, making the elastic collision, coming back again, hitting with u and again coming back with the same way speed u, they may say. In that case, what happens is change in momentum is not mu. Change in momentum is mv minus mu. mv also same, mu also same, but opposite direction, that is the change in momentum becomes equal to 2 mu. If velocity is backwards, then you have to take it as a 2 mu. So double to this force you will get, that is 180 into 2, 360 newtons. Careful with that problem. The bullet may come to rest or it may rebound with the same speed. And student, next problem 118. A machine gun fires bullets each of mass 40 grams at speed of 1200 meter per second. Careful with this, 40 grams is not, this G is not an acceleration to gravity, it is a unit of the mass. Man can exert a force of 145 newtons on the gun, means holding purpose. Same question can be asked as a friction force also. This may be asked as a force exerted by the person, or it can be also, same question be asked in terms of the name friction. So gun, you are firing the bullet. When bullet goes forward direction or recoil velocity comes backward, the velocity of the gun, this is the velocity of the bullet. M into U is supposed to be equal to M into V, negative sign. Both are equivalent. Momentum of the bullet is supposed to be equal to momentum of the gun. This velocity of the gun backward direction is called recoil velocity. To hold this gun, he has to apply the force on it. So a person should hold it, applying the force. When the force acting backward direction, he has to stop it by applying the force which is appearing as a friction force between his hands and the gun also. In that case, that what is the force exerted by the person? Force is nothing but equal to change in momentum by time of the bullet. Bullets were initially at rest and finally traveling with velocity v. You may take it as a u also, only one velocity is there, other velocity starting from rest, so you can take it as a mu or mv, that is left to your choice. Number of bullets fired is nothing but equal to n. N into total momentum change is nothing but equal to n into momentum of each bullet is nothing but total momentum change is nothing but equal to force with the time, change in momentum by time, sorry. Then number of bullets fired per second is n by t. N by t you have to find out. N by t cross multiplication equal to f. N by t is f by m, mass into velocity. Force is given how much is 144 newtons. By mass of the bullet is 40 grams converted to kgs, 40 into 10 to the power minus 3, and into velocity speed is 1200 meter per second. These three zeros cancel with the power. 12 to the 12, 144, and result by 40. Result is 3 bullets per second fired. Next question is 121. Find the acceleration of the wedge, means triangular wedge, to keep the block on it at rest. You are pushing this block forward direction with some total force. Okay, the block, this wedge mass is m and block mass is small m. And pulling forward directions, if it is not moved, this will slide downwards. No friction, please. Frictionless smooth surface would imagine, not mentioned, take it as a smooth surface. So it has to slide downwards. If friction is there, friction opposes the sliding, opposite direction it acts. The weight mg is always vertically acting downward towards the center of the earth, and here is the smooth. Or even if friction is there also, this one is not important here. That is second part of the question. Pull forward direction, then pseudo force on the block acts in backward directions. The pseudo force is supposed to be equal to F is equals to the block mass into acceleration of the whole system, that is A. That acting backward direction resolved into components. Weight is acting downwards and pseudo force, the angles you have to be careful, please. This alpha means this alpha means this alpha. So in these directions F cos alpha, and in this direction is F sin alpha. And downward direction is, because the weight component we get is equals to mg cos alpha, mg sin alpha. If it is given theta, replace alpha with theta. But you take these components and there is no sliding down at rest. At rest means on it at rest. At rest means you have to take block at rest along the inclined surface, means the total force is 0 along the inclined surface. Normal reaction is, however, is balanced, particular direction normal balanced by this force, and the mg sin alpha equal to mg cos alpha. Previous case what we discussed is normal reaction 0 component condition we have taken before, that is moving in the opposite direction, left side. Now we are moving in this right hand direction, so the block is at rest, not sliding downwards. Then downward force is balanced by the upward force on the inclined surface. That means F cos alpha is supposed to be equal to mg sin alpha. F equal to ma pseudo force equal to cos alpha equal to mg sin alpha. Mm cancels, a equal to g sin theta by cos theta is equal to tan theta. You don't have to solve this again. Please remember this condition. This is a equal to g tan theta. Previous case what we said, falling freely conditions case is a equal to g tan theta, opposite direction to take. In this question they may ask total force. Total force is nothing but equal to F equal to m plus m into a equal to g tan theta, and total force you are applying on this block, smooth surface on this, is F equal to m plus m into a. This may be also asked. Next 132 question number. It is a lift problem. Inside the lift, person is there and lift is at rest or moving with uniform speed. Moving at rest or velocity is constant, then in that case acceleration is 0. In such case apparent weight is nothing but equal to true weight. Apparent weight is the weight what we are seeing it. If the person is standing on the weighing machine and you are exerting the weight downward, the reaction force acting on you is the reading you see. If there is no reaction force, there is no reading. If the freely falling condition you have taken, you are inside the lift is falling freely, then the apparent weight, you don't exert any weight downwards, the weighing machine also do not exert the normal reaction on you, the net force is going to be 0, then apparent weight is also 0. The person feels weightlessness, not exerting anything, any force on the on the object below him. So in the normal reaction symbol may be given as capital R or N. I am taking it as N here. N equal to mg if lift is at rest or moving with uniform speed. Velocity is constant, upwards or downwards. This is a constant speed or 0 or acceleration 0 conditions. Apparent weight equal to true weight. Next condition is here, in this question they have given these two conditions. Accelerating upward direction. When it is accelerating upward directions, upward force is supposed to be equal to n. This mass of the person is m. So upward force normal reaction n1 plus ma, and downward rate is nothing but equal to mg. So this resultant force is nothing but equal to upward force minus downward force. Going upward means we have to imagine that n1 is greater than mg. n1 minus mg equal to ma. Taking this n1 substitution, what you get is apparent weight is nothing but equal to mg plus ma. Careful with this, directly you have to remember the upward directions, upward acceleration, upward velocity is no. Velocity means true weight only you will get. Acceleration is there only, you will get the change of the weight. So apparent weight becomes equal to mg plus ma, upward directions, m you can take out common, g plus a. Same thing happens when the inside the giant wheel in the exhibitions, when it is going upward directions, the seat pushes you up, accelerates, we feel our weight increasing. That is the apparent weight we feel. Not true weight, actual weight do not change, that is always mg only, we feel it. That is the apparent feeling, that is n1 equal to mg plus ma. More acceleration upwards, more apparent weight. Next case is lift is accelerating downwards with acceleration a equal to meter per second square, 2 meter per second square. Apparent weight is nothing but equal to, now mg is downwards, this person here weight is m into g, mg is downwards, normal direction upwards, so mg minus n2 equal to ma. The result becomes equal to is m2 equal to mg minus ma. Freely falling cases means a equal to g only, it becomes downward directions, mg minus mg is 0. So if you take the free fall a equal to g downwards, therefore apparent weight equal to 0. The free person feels weightlessness. If the a is more than g downward direction, then person leaves the floor and floats upward directions. Next, change in apparent weight they ask. Change in apparent weight, this n1 minus n2 is equals to how much? Mass of the person is given as 60 kg. So mg plus ma minus of mg minus ma. Minus mg minus into becomes equal to plus 2 ma plus ma. Minus mg plus mg cancel. So what you get is 2 ma. 2 into mass is 60 kgs into acceleration is a. Upwards or downward directions. If accelerations are given different, you have to take it as a1 and a2, substitute that values. The result is 240 newtons. It is a force. Apparent weight is nothing but equal to force. Next 133 question number. a weight is suspended with the rope inside the lift. Lift is moving upward directions. Just as before, if it is moving upward directions, remember weight increases. Here tension increases. Moving downwards, the weight decreases. Here also tension in the rope decreases. See, but question given as acceleration is upwards. What if the falling freely? Falling freely, tension is 0. Tension is there means rope is tight. Tension is not there means rope is loose. It becomes. M is 6 kg block suspended with rope in a lift accelerating upwards at a 2.1 meter per second square. Tension in the rope is how much? Upward direction tension equal to mg plus ma. M into g plus a, substitute the values here. Mass of the block is given as 6 kg, g 9.8 not mentioned here, g 9.8 you can take a plus 2.1 into 6 is approximately 71 newtons. If the actual problem that is given as 2.18, so this is going to be nearly 72 newtons. Nearest options you have to choose in that case, near approximately equivalent. Next 135. Capital M is the mass of the block, small m is the rope tied to it, and length of the rope is L, is pulled with a force equal to F. And what is the tension in the rope at the half of the length? Uniform thickness they gave you, uniform rope mass is proportional to length. If length is half, mass is also becomes equal to half. And they asked at the midpoint what is the tension. The tension is nothing but we called as a contact force, F prime we can take. Contact force is Fm, which is also appears as a tension inside the ropes. Tension is nothing but a force inside the materials. So total force, if you take a total force is pulling both the rope as well as the block. Okay, no friction please. Smooth surface you are imagining here, no friction. So F equal to m plus m into total force. M plus m. This m plus m into a. Connected bodies with the same acceleration. Rope is inextensible. Ideal rope is do not have mass actually, but here we are taking the rope which is do not extend, like rubber it should not expand. In that case only total force as force appears to be transferred, but mass is there. If mass is not there, same force appear here and everywhere also same force will take it up. Mass of the rope taken means what? Tension changes from point to point. In such case, in this case what they mentioned is half of the length they mentioned, x equal to L by 2 they mentioned, so m becomes equal to m by 2. At that point what is the contact force? So total force F equal to m plus m into a, and a equal to F by m plus m. Force by total mass is acceleration. This is same for the all connected bodies. Next, contact force F. Spring is there means this formula is not applicable please. Contact force F at midpoint, middle of the rope. Middle of the rope is m by 2, total mass is m. The contact force between the two ropes m and m in between. This contact force at the middle of the rope they ask. At middle of the rope pulls from here. This part is pulling this remaining part m by 2 and m at this point. They may ask at any length that you have to check which that remaining length from the one end. If they give the length which remaining length only you need to consider here. Half length you have taken. Sometimes they will give the different distances, different lengths also. Here half. So this contact force here at tension in the rope is pulling m by 2 plus m. Total mass is m by 2 plus m. Symbols careful. Capital M is the block mass, small m is the rope mass. So m plus small m by 2. F is equals to, the contact force is nothing but equal to small m. F symbol you have taken, it can be taken as a tension T is equals to m plus m by 2 into a. This is about contact force is pulling. This is the mass contact force is pulling, and a substitute from here. A equal to F by m plus m. LCM you take 2m plus m by 2 into F by m plus m. You just need to be careful with the symbols, which is capital M, which is small m here. Next, 138, similar problem. Total force F is pulling the rope and block. Rope and block. Rope mass is m, block mass is capital M. But now they asked is, what is the force exerted by the rope on exerting the force exerted by the rope on the block, or block on the rope means contact force between these two you have to take. Action reaction force are equal place, one with these two. Same thing here, tension right side, left side also same. Then force which is pulling is symbol given as a P instead of F. So just F replace with the P. Total force F is equals to m plus m into a. A is same here for the connected bodies. Inextensible rope we are taking. But contact force between this block and rope is F is equals to, this contact force is pulling only capital M. So F equal to ma. A you have to take it from the previous relation. A is equals to F by m plus m. F is replaced with P. The formula is F equal to mp by m plus m. Next problem, 139 question number. Three blocks, it's connected bodies. Three blocks connected with the massless ropes, negligible masses of the ropes and ideal ropes. No mass, no extension of the ropes. Find the tensions between them. They ask only one tension, but let us work out all. Total force applied on the all blocks pulling for right hand direction is 40 newtons. Is the total force taken as F3 given. Take it as a F. F is equal to total mass into acceleration. Connected bodies have the same acceleration A. So F equal to m1 plus m2 plus m3 into A. First find out what is the acceleration. A is equals to F by total mass. Any acceleration is always formula is net force. Any opposing forces, frictional force is there, for example. Frictional force is there means F1 plus F2, F3 all frictional forces sum. You have to take the external force minus frictional force equal to total mass into acceleration. This is going to be net force. Difference opposite direction means difference force. Denominator always total mass is acceleration. So in this case only not mentioned of the friction means take it as a smooth surface and no friction. Only one force is acting, that is 40 newtons external force. In the direction all blocks are moving right hand direction, so acceleration is right hand in the diagram. Acceleration equal to F by total mass. F is 40 newtons by total mass is 10 plus 6 plus 4 is equals to 10 plus 10 20. 40 by 20 is 2 meter per second square is the acceleration, same for all blocks. And for the first block, last block, if you have taken this is given as m1 actually, compared to the force is the last block. And m1 is there is no other force acting left side, only one force is there. There is a tension in the rope T1. T1 is equals to m1a. T1 is equals to m1a for the block m1, and that is nothing but equal to m1 is 10 kg into acceleration we got is 2. 10 into 2 is 20 newtons is the force acting, tension acting here. This is nothing but equal to 20 newtons. Next, what is the tension T2? Second block, this T2 is pulling both m2 and m1. So T2 equal to, we can take it as equals to T2, we can take it as equals to m1 plus m2 into A we can take. But here I mentioned it as, we can also take it as T2 minus T1. This T2 is more than T1. T2 minus T1 is nothing but equal to m2A we can take. Like this we can take, or we can take it as T2 is equals to m1 plus m2 into A. That is 16 into 2, 32. You can also take this T2 is equals to m1 plus m2 into A. T2 is pulling these two blocks. m1 plus m2 is 6 plus 2 is 16 into acceleration, common acceleration is 2, which is nothing but equal to 32. Or we can also take T2 opposing force is T1. Net force becomes equal to T2 minus T1 is equals to m2A, 6 into A, 12. But we want T2. T2 equal to T1 plus 12, 32. We can do like this or like this. Next, for the m3, this is not required. Actually, we found that T3 is given, but still equation we can take for this m3. T3 minus T2 equal to m3A. Relation we can take the difference in the force. This is what we can find is in between the blocks. One force is T1, another force is T2, 32 newtons. T3 already given. Next, question number 144. In this question number 144, triangular wedge is taken and angle of inclination is 30 degrees. One block is taken over the pulley, suspended down with the weight mass equal to m2 equal to 4. If they give kg weight means that is a mass. Converting into newtons into g you have to take. And on inclined surface, block m1 80 kg is kept, and both are tied with a string, which is ideal rope, inextensible, massless. Then this, let us imagine the acceleration, any one direction acceleration we can take. For example, let us take this block is having more weight and more force exerting down, so it is moving down with acceleration A. When two forces are equal, net force is 0. Net force is 0 means if the block may be at rest or moves with uniform velocity. Let us imagine that this weight force is more, net force is not 0, then this what is more means it going downwards. Let us imagine any directions. I am taking the acceleration downwards here. Acceleration downwards means the m2g is more than the tension in the rope upward direction T. Same tension, same opposite direction forward and backward with respect to the objects we have to take. Free body diagram, if you take only this block m2g is downwards, tension is upwards. So it is moving down, we have mentioned means m2g minus t equal to m2a, net force equal to mass into acceleration for this block. So the m2 is given as a 4, g I am taking it as a 10, not given, you take it as a 10. So 40g, 4 into 10 is 40. 40 minus t equal to 4 into a is one equation. Taken as a g is equals to 10. Next, for the block m1, tension in the rope is along the inclination upward directions and weight downwards is mg sin theta. This is a theta, this is a theta. The weight is vertically downwards, dissolved into two perpendicular components. Along the inclination is sin theta, along the perpendicular to the surface is mg cos theta, which is balanced by the normal reaction. So this side only unbalanced force try to move if it is not balanced. unbalanced or balanced, we have to verify now, because one more opposing force is acting here. Friction is not there. If friction is there, what happens? This side is the friction you have to take. Frictional force, tension, Ft plus F is equals to mg centimeter at rest. Means if it is moving upward direction means acceleration here, block is moving down, so it is going up. So T plus F minus mg centimeter is equals to m1a is the resolution you have to take if the friction is there. But in this question not given. That friction problem will be given only, this kind of things are there also, will be given only for JEE advanced, not even main also, most probably this time, this year. So next equation for this m1 is T, where imagine that is going up, therefore T minus m1g sin theta is equals to m1a. T minus m1g sin theta equal to m1a. Sin theta, theta is 30, sin 30 is half. m1 is 8 into g10, 80 into half is this a 40. T minus 40 equal to 80a you will get m1a. And solve these two equations. One equation is 40 minus t equal to 4a, another one is t minus 40 equal to 8a. Adding these two equations, if you take first t minus 40 equal to 8a, 40 minus t equal to 4a, just to take the addition, then t minus t 0, 40 minus 40 is 0, left side you will get is 0, 0 equal to 12a, 0 equal to 12a, that means acceleration is 0. Acceleration 0 means velocity is constant or velocity is 0, both are possibilities there. If it just disturb it, if it is net force is 0 means give a small push, it goes with the same speed this side. If a small push, if this given this side, not go that side. So we are taking here smooth surface, no friction please. It is an equilibrium we can say. Two kind of equilibrium, if it is at rest, static equilibrium, if it is moving with a constant velocity, dynamic equilibrium. Next 158, this is very important question, multiple times asked even for NEET. Two weights are taken, two blocks are suspended with a rope. Top one spring is there, expanded. Afterwards, if it is bottom block connected string, negligible mass is broken. Then this 2m mass will be pushed upwards. Initially it is downwards, but now spring will go upward directions. And they asked is what is the acceleration upward direction of the string between these two breaks. Here it is broken. String breaks. When string is not broken, tension will be there, the string will be tight. The weight acting downwards is nothing but equal to this tension between these two. T1 equal to only this balancing the downward weight mg. At rest, both blocks are at rest initially, mg. So T1 is equals to mg. But T2 is nothing but equal to this string is balancing two masses, 2m plus m. 2m plus m into g means 3mg. Upward force equal to 3mg it becomes. Next, when string is broken, then downward force is now not there, only upward force will be there. In such case what happens is previously it is balanced. When balanced, the upward force is 3mg, downward force because of this was mg. This because of this is mg. Then in that case, when it is broken, at that instant, fraction of second, just at the instant, upward force is 3mg, downward force is mg only. So resultant acceleration will be upward directions, that is 2m into a. So 3mg minus mg. Sorry, this mg is not there anymore. We take it is equals to 2mg. Downward weight is equals to 2mg. But upward force is nothing but equal to 3mg. This is broken out, it is not there anymore. Now the force is nothing but weight downwards is only 2mg. But at that instant, fraction of second, the tension in the spring was equal to 3mg upward directions. So 3mg minus 2mg equal to 2m into a. 3mg minus 2mg equal to 2ma. Then this is going to be mg equal to 2m into a. Mm cancel it, acceleration be equal to g by 2. So one acceleration is g, another acceleration equal to g by 2 upward directions. One is freely falling downwards directions. I will stop here, and level 4 is only for JEE problems and NEET also. I will give you the hints for the problems in the material.